Hello, 8.5! We're going to be solving three-dimensional linear systems.
How?
Ooh, elimination! But then, whatever you want.
Sick. Now, we've got this system here. It's not just in terms of X and Y. It's got a Z in there. This is a 3D system. It exists in 3D space. How in the heck do we do this? It is not quite the doozy that it might initially appear to be. We do know how to solve a two-dimensional system.
Oh, yeah.
And we have a couple ways to do that. We have graphing it, which is probably not an option for 3D systems for us. We can also use substitution, which does work for 3D systems, but the most efficient one is elimination. And if we can eliminate a variable a couple times, if we can turn this into a 2D system, well, we can solve the whole thing. That's what we're going to do. First, I'm going to number these. I'm going to call this one number 1, this one number 2, this one number 3. Technically, the numbers you use there don't matter as long as they're all different. I recommend 1, 2, and 3 because they just make logical sense. Now we're going to choose a variable to eliminate. And just as when we played with elimination, we have options. We can decide we're going to eliminate X, or we can decide we're going to eliminate Y, or we can choose to eliminate Z. The choice is yours. Personally, I would not go with X, because we have a 3 and a 5 and a 2, and just making those same is gonna be an issue. Not the biggest issue, but it's just more work than I need to do. Y isn't the worst option. I mean, these two are already same, and multiplying this by 2 gives you the 4, so that's not the worst option. But look at those juicy Z's. Oh, look at that coefficient. You see that coefficient?
Oh, so nice.
Yeah. Oh, yeah. I like that coefficient of 1. And for that reason, I'm going to pick Z.
I also endorse this decision. Thank you.
Now we're going to pick two equations, and we're going to combine them to eliminate that particular variable. I'm going to pick equations 1 and 2. If I go with equations 1 and 2, I don't even have to modify the equations. Those will straight up add to get rid of Z. Okay. So equation 1, C as something.
3x. Yeah, you got it.
Yeah, I got it. I have skills. I just memorized it, actually.
Dang.
Yeah. And equation 2 says 5x minus 2y plus z is 4. I wanted to eliminate z, just double check. The coefficients for z are same, but opposite. So I'm ready to add these. And when I do, I say 3x plus 5x is 8x. 4y plus negative 2y is 2y. Negative z plus z is nothing. It's dead to us. And 8 plus 4 is 12. This we will call this color. Equation 4. We're going to eliminate z again, but not by combining equations 1 and 2. That's done. We're going to use a different combo. We can go with equations 1 and 3, or we can go with equations 2 and 3. We're just not going to go with 1 and 2 again. Let's go with 1 and 3. Again, because these are already opposites, I think that's a good way to play things. So equation 1 is still 3x plus 4y minus z equals 8. And equation 3, which I memorized, is 2x minus 2y plus z is 1. It's an impressive memory for an 80-year-old. What can I say? I'm going to add these together. 3x plus 2x is 5x. 4y plus negative 2y is 2y. And negative z plus z is nothing. 8 plus 1 is 9. Woo! Equation 4 and equation 5 together are their own two-dimensional system of equations. So for the time being, we're going to ignore equations 1, 2, and 3 and just check out 4 and 5.
All right, so now that we have 4 and 5 representing our new 2D system, we're going to start by writing those guys out. So we have 8x plus 2y is equal to 12, and 5x plus 2y is equal to 9.
Dang, you memorized those two?
Yeah, boy.
Skills.
All right, so we're going to go ahead and pick a variable to eliminate. And in my head brain, it looks like our y's make most sense, but one of those have to turn negative, right? Because if we have both of them as positive 2y, we need to have the additive opposites, so one of them has to become negative 2y. So here, equation 1, I'm just going to leave that one as is. I'm going to do nothing to it, or you could say I'm multiplying it by 1. But in equation number 5, I'm going to multiply that guy by negative 1. And this is what I'll get. 8x plus 2y is equal to 12, and then negative 5x minus 2y is equal to negative 9. And here I am, all happy in happy land, seeing that I have additive opposites for my coefficients for y. Now, I've got them stacked, and I could go ahead and straight up add. 8x plus negative 5x gives me 3x, 2y plus negative 2y gives me nothing. And 12 plus negative 9 gives me 3. If I divide both sides by 3, I end up with x is equal to 1. What? Cool. All right. So, what I can do now is I can go ahead and plug my value for x into either equation 4 or into equation 5. I can choose. And because I gotta choose, I don't know, maybe I'll put it into equation 5 for no good reason? Sure. Okay, so I'm going to sub info into equation 5. Oh, and I want to underline that because, yes. So, I have 5x plus 2y is equal to 9, and I'm plugging in x as 1, so I have 5 times 1 plus 2y is equal to 9, so I have 5 plus 2y is equal to 9. I subtract 5 from both sides as if I'm in some sort of race, and I get 2y is equal to 4. Divide both sides by 2, and I get, whoops, y is equal to 2. Boom, bam. But I'm not done. I'm not going to be like, oh yeah, here's my coordinate solution point of x comma y, 1 comma 2. No! We's in a 3D system now. So, what we've got to do at this point is we are going to then pick one of our original equations, equation 1, 2, or 3, and we are going to plug in the value for x and the value for y that we found, and now solve for our final variable, which is z in this case. Okay, I'm going to, for again, no good reason, I'm going to sub info into equation 3, mostly because that's the one that I have memorized in my head. So, I have 2x minus 2y plus z equal to 1. And I'm going to go plug in 1 for x, 2 for y, nothing for z, because I don't know what that is. And I'm going to collect my like terms. I'm going to simplify all that beautiful jazz. Well, not the like terms, but I'm going to move all the numbers to one side, solve for z. Life's going to be good. So I have 2 minus 4 plus z is equal to 1. 2 minus 4 is negative 2 plus z is equal to 1. If I move the negative 2 over, I get z is equal to 3. Now we've got a solution, but I can't just leave it as that. I need to state it. So just like we said before in our 2D system, we said our point x comma y was equal to blah, blah, blah. We are going to say our point x comma y comma z is going to equal to 1 comma 2 comma 3.
Oh, isn't that just a cute little answer?
I know, it worked out so nicely. Now, Just like our optional step 7 from before, we also have an option to double check our answers. So we used equation 3 to solve for z. We've plugged in our information for y and x into equation 3. What we could do, and it would really be a good idea, especially if you want to make sure all of your answers are correct, is we can plug in the values 1 for x, 2 for y, and 3 for z into equations 1 and 2 to see if they're also solutions. And if they're solutions to all 3 equations, then we know for a fact it's a solution to our 3D system. Alright, so here I'm going to check 1 over there. I'm going to check 2. And I'm going to do it in purple. So, just like before, we're going to have our left-hand side and our right-hand side. We always do this when we're checking to see if a point is a solution to our equation or to a system. So on my left-hand side of equation 1, I have 3x plus 4y minus z. And when I plug in my points, I have 3 times 1 plus 4 times 2 minus 3. And I get 3 plus 8 minus 3, and I get 8. Oh, baby. On my right-hand side of that equation, I just have 8. Life is G. And my left-hand side is, in fact, equal to my right-hand side. So I know that point is at very minimum a solution to my equation 1. But to make sure it's a solution to my system, since I already know it's a solution to equation 1, solution to equation 3, I need to also check equation 2. And I do that by, again, splitting it up to my left-hand side and my right-hand side. My left-hand side for equation 2 happens to be 5x minus 2y plus z. And I plug in a 1 for x, 2 for y, and a 3 for z. I get 5 minus 4 plus 3. And that happens to be 4. And my right-hand side, it's 4 as well. Wouldn't you know? My left-hand side is equal to my right-hand side. So I know for a fact that this is a solution, the proper solution, to my 3D system.
There's a lot of things to keep track here. We've really broken this down into all these steps here, there, everywhere. I mean, you don't need to formally write that you pick a variable, but we've broken things up here. The thing is, there's a lot of steps, and a lot of those steps are just basic arithmetic, adding, subtracting, maybe some multiplication, division here and there. But because it happens so many times, it's very easy to just make the tiniest error at some point in this. And if you do, it could throw everything off. If you find that something doesn't really seem correct, if maybe you're working through this and you get an answer of 117 over 74, or something that looks like really weird, like maybe I shouldn't be getting that. Just double check everything. Did everything happen correctly? Just check your work, take your time as you do every single step. Cool beans?
Cool beans.
Cool.
Beans.
Cool.
Beans. That's much harder.
Beans. Alright, we're going to solve these two 3D systems. It's going to be wicked cool. I think I'm going to go with y. I'm going to eliminate y. I'm going to... We're going deep. And I'm going to go with 1 and 3 first, personally, just because I see them being opposites, super duper. So equation 1. Also, don't forget to just try these on your own. See what happens, and then check this video to see if you did it all good like. Doo-doo-doo. So that gives me 6x. The y's eliminate. Equals 2. Yeah, that's good. trying to decide, do I want to divide this all by 2 right now and make it an easier equation? I guess I don't really have to. Alright. I'm going to eliminate y from 1 and 2. But in equation 2, there's a 2y, not just a regular y. So I'm going to multiply equation 1 by 2. I know for me, this is where I tend to make mistakes the most. I'll just forget to multiply one of these coefficients by something, and then I really pooped in my cornflakes. So just watch out there. Where do you make mistakes? I don't know. You figure your life out. Actually, wait, where do you make mistakes? Do you know where you make mistakes?
That is for sure just a common one. Basic arithmetic every now and then. Because like Mr. A was saying earlier, there's so many times where you're just adding things, or not subtracting things, well, adding things, or multiplying the equations by a constant. And because it's happening so often, it's really easy to just make those mistakes. So, like Mr. A was saying, if you see something that just doesn't really make sense, or if you're going through your work and you're getting an answer that doesn't make sense, make sure you backtrack and try and find your mistake. Because realistically, at the end of the day, going through your own work and correcting it yourself is going to help you a lot more than double-checking answer keys and finding where mistakes happen, right? So you're going to get a lot more out of it that way. So, again, take your time, check your work, but you can do it!
You really can. Also, x is 0, so that's kind of exciting. Alright, I found x. Color switch. I'm going to plug into any one of these equations. Let's sub into, I'm going to go with equation 4. Well, 6 times 0 is 0, so really I just have negative 2z is 2. Z is negative 1. I eat. And then, let's go back to my purple, because that's what I was using when I was in 3D mode. I'm going to pick equation 1. Which said stuff. 2, negative 1, negative 3, negative 1. And plug in what I know. I know x is 0. I do not know why. No, I do know why. It's because I solved it to make it 0. I don't know the value of the letter y. No more jokes. Alright. Gonna punt my y to the other side. I'm gonna add 1 to both sides. Shaboom! And this. X was 0. Y was 4. Z was negative 1. Not gonna lie, I've screwed up at this step right here as well.
I was gonna say the same thing.
Yeah, like, it's like, okay, I found X, I found Z, I found Y. Let me state my answers that I found completely correctly, and then I just mess up the order. I'll be like, I found this first, and this second, and this third, and just ruin everything. It's devastating. So, watch out for that. Oh, my hand's tired. Can someone else do this next example?
You know what? Honestly, my hand's a little tired too.
I believe in you.
I'm just kidding. Alright. In order to get swole, we must power through.
I wouldn't know.
So, what we're going to do, same, is we're going to start off by labeling these equations 1, 2, and 3, and we're going to check out a variable to eliminate. Honestly, I'm taking a peek here. It really just could be anything. They all look equally appealing to me, because I could go and combine these equations 1 and 2, all I have to do is multiply equation 1 by negative 3. I could do 1 and 3 multiply equation 1 by negative 2. But same for these guys here. So I could multiply equation 1 by negative 2. I could multiply equation 1 by positive 3. There's really not more work in choosing either of these variables here. So just for the sake of why the heck not, let's eliminate x. Or at least that's what I'm going to eliminate. If you have already started this and you've eliminated something else, your answer will end up being the same as mine, provided you and I both do the work correctly. But your steps might look a little bit different, and that's okay. So I'm going to eliminate x, and at first I'm going to be looking at equations uno and dos. And that's going to be these guys here. And I'm going to have to multiply them by things and such. I don't really have to do anything to my equation 2 here, but for my equation 1, I'm going to multiply by negative 3. So I get negative 6x minus 3y minus 3z is equal to 0. And then I get 6x plus 2y plus 3z is equal to 0. And that's just so wicked, because if I look at this and I add these two equations together, negative 6x plus 6x, boom, she gone. Negative 3y plus 2y, boom, negative y. Negative 3z plus 3z, boom, she gone.
Whoa!
And, ooh, yeah.
That's crazy.
0 plus, I done goofed here. Look at me. This is the mistake I commonly make.
Honestly. Someone just got a transcription error.
Yeah. But hopefully I would have checked my work.
Yeah.
As I went back and realized, oh, she made a mistake.
Like you did just now.
Yeah. And that's okay. And I end up with 0 plus 3 is, whoop, oh, so nice. 3. Whew! And so if negative y is equal to 3, to solve for y, I get y is equal to negative 3.
Yeah, and you've already got a variable value? That's crazy.
I know.
Like one step in.
Yeah. Okay. From here, I can do a lot of things. So I'm going to try and do another combination of my first set of equations. I did 1 and 2 first. I'm going to do 1 and 3 next. That seems reasonable. There's a hair on my screen. Okay, so I have 2x plus y plus z is equal to 0 for equation 1. And for equation 3, I have 4x minus 3y minus 4z is equal to 3. My x, which I'm still trying to eliminate here, to get those coefficients to be additive opposites, I'm going to multiply my top equation, my equation number 1, by negative 2. And I'm going to get the following. Negative 4x, negative 2y, negative 2z is equal to 0. And my bottom equation is going to stay same. Now, my coefficients for x are additive opposites, so I get negative 4x plus 4x. Boom, she gone. Negative 2y plus negative 3y. Ooh, negative 5y. And negative 2z plus negative 4z is negative 6z. And 0 plus 3 is 3. Alright. At this point in time, I have a value for y. And I have this equation. Just for the sake of naming it, I'm going to call this guy into equation 4. What I can very well do is I can solve for x in equation 4. Right? Because I can plug in the value of y that I know, and I can solve for z. Alright, so let's do this. So I have negative 5y minus 6z is equal to 3. And I'm going to plug in a negative 3 every time I see a y. So negative 5 times negative 3. minus 6 times z is equal to 3. I get 15 minus 6z is equal to 3. I'm going to scoot the negative 6z to the other side. So I get positive 6z, which means I'm going to scoot that 3 over to my 15 side, which will give me 12. And if I divide both sides by 6, I get z is equal to 2. I've got 2 variables so far. L is G. Life is good. What I can do is I could sub that info into one of my equations of my original 3D system. And it could be either one. It doesn't really matter. I'm going to choose 1, 2x, 1y, 1z, 0. Because it just seems easier here. 2x plus y plus z is equal to 0. That was the same, right? 2x plus y plus z, 0. I'm often bad for making transcription errors. That's my kryptonite. Right? Yeah.
Yep.
So, I'm going to go ahead and plug in my negative 3 for my y, and I'm going to plug in my positive 2 for my z. I'm going to solve for my x. So 2x plus negative 3 plus 2 is equal to 0. So I have 2x minus 1 is equal to 0. So I get 2x is equal to 1. Divide both sides by 2. X is equal to 1/2. All right. I know that at least a lot of you panic when you see fractions. Yeah, like just really freak right out. Fractions are okay. Right, if you see weird fractions like that 117 over 74, I think are the numbers that you used before, then maybe we didn't give you a question that used those. It could be possible, though. It's not out of the realm of possibilities, but for the sake of us just learning and practicing together, you're probably going to get a little bit of nicer numbers. But 1/2, oh, she a beauty. So, our final answer must be stated as such. We know that x is 1/2, y is negative 3, and z is... Ooh, just made a straight little line there. I didn't know
No, the
that.
undo doesn't tackle it for whatever reason.
Yeah. Okay, sorry about that. Negative... Oh, I don't like that 3. I like my original 3. It's better. And z was 2. Okay, so we made sure that we stated them in the right order, because again, that's additional kryptonite for me. But we're stating our final answer here. That is it for today's lesson. On the next page, you have some practice. Okay, so please take a peek at these. There's 6 questions. Go ahead and take your time, check your work. But you could do it. You could do anything. That's it. You say bye?